Oh, baby! Oh, it's beautiful, guys. It's beautiful. It's a beautiful. So guys, keep using that canola oil to protect your threads. Alright, otherwise you're going to end up with beading on your threads, then you'll need to run a dye and it'll be painful, okay? Just keep the canola oil cranking. And I love the fish and chip shop smell anyway. It is going to mean, guys, that we're going to have an additional step in cleaning this before we can paint it. But that's a lot quicker than having to run dyes and stuff like that on threads. So guys, that's it, that's in place. Make sure they're a good penetrative weld. Now this material, guys, that I'm using here, as you'll see in the mid-frame build for the 3 degree of freedom, when you access that tutorial to build this bracket, this is 4mm thick material, okay? It's a 65 by 35, 4mm thick into 5mm. These are actually 6mm pieces that I've got here, my scrap, but you'll have 5mm, don't worry about it guys, more than adequate. 6mm is overkill, but it's what I had lying around. So you'll get good penetration between these guys. This will be a very strong weld, alright? So you've done that now guys, you can let that cool down, then you can separate these two pieces. Like I said, I've got to take this off now to do some work to this. And that is your front motor mount trolley basically sorted. Let's set up our plate for our uni joint trolley carriage. Very similar setup to the front motor mount, but orientated differently on the trolley, guys. Instead of it going like this, all right, this one, we have to orientate it in this direction. The reason being, when our uni joint goes on, we'll have a coupling system here that joins to our surge motor. Our surge motor rod and our lever will attach to a part welded on the back here, and that pushes our top frame forward and backwards. So this is how we orientate it. So the first thing to do is grab your calipers, turn them on, make sure they're zeroed, find the 50mm mark. We're going to mark right up the center of this piece, 50mm guys, and straight up the center lengthways of this. Now I'm going to mark this in stronger. Unfortunately, my veneers are starting to get very, very blunt. I will need to resharpen them. I'm just marking them in with my normal scribe at the moment. Okay, 2 measurements we need. Now this center mark we're making here, guys, is for our plug welds, like we did on the first one. Okay, make sure it's zeroed, 10mm. And then this will now be the front. Right, scribe in a line along here, 10mm. Right, then guys, take your calipers back to the start, zero it out, 68mm, 68mm, scribe that in, 68mm from what is the front now, get a line scribed in. Now where the center line here intersects with those two lines here and here, that is a 10mm drill bit. So that's where your plug weld, that's where this will be sitting on, and you'll plug weld through this, guys, into your rod like we did with the first one. Now our bolt hole locations for our M8 bolts. Take your veneers, open them to 25mm. From the front again, guys, 25mm. Close your scribe, turn it on, zero it out, 80mm, guys. From the front again, okay, so you've got some lines in here reasonably within reasonably close proximity of each other. So you'll have to be careful not to mix this up though. The next measurements will aid you in not doing that. Okay, close your veneers, zero them out, open them to 10 mil, guys. Now along both sides, along both edges, scribe in a 10 millimeter line. That's it for our veneers. They've done their work here. Put them away, guys. Make sure they're protected. I'm just going to scribe these in so I can see them and I don't lose them when I clean my material off. So we will drill this before we sand this off. The good news is, like the last plate, we only need to do one side of these two plates. That's all that will be seen. Okay. Your 10 millimeter mark in the center is a 10 millimeter hole. Your 68 millimeter mark here, guys, in the center is a 10 millimeter hole. Your 25 millimeter line in here at where the 10 millimeter from the edge marks are, where they intersect. This is your M8 bolt location. Punch that. Over this side, punch it. And then our 80 millimeter mark here, all right, where these lines intersect on the 10 mil, punch those, all right? Watch what I do here so you won't go wrong. So on the 10 millimeter, we punch in the center. In the 68 millimeter, punch that. Now these guys, this line and this line, these are punched over on the 10 millimeter inboard lines. Here at the 25 mil line this side. This one. And that guy there, 80 millimeters. So you've got a punch mark here at your 80 mil, here and here. At your 68 millimeter line from the front, your punch mark is in the center. Your next line back here, 25 mil in, punch, punch, and then the 10 millimeter line in here at the center line, punch there. 10 millimeters, 10 millimeters, 8 millimeters, 8 millimeters, 8 millimeters, 8 millimeters. Same story, guys. Get these sandwiched, all right? Make sure they're lined up. And we're doing exactly the same as we did with the first two plates. We're just going to tack them to keep them together. Exactly the same routine as the previous plate for our front motor mount. Grind off your rod very gently to get that thread ground down to a flat surface for your plate to sit on. Mark 85 millimeters along your rod, both sides. Make sure that you are orientating your plate on the side where your bearings are the furthest apart. Mark 85 millimeters to the center of your rod. Place your weld plug holes over those marks. All right, line them up on those marks and then double check. You should have 50 millimeters from the outside of your plate here to the outside of your trolley plate. For it to be square, all right, 50 millimeters from outside to outside. Once you've got that squared up, you'll need to clamp it so it doesn't move when you do your plug weld. Make sure you've cleaned up this plate underneath. This time the doctor remembered to turn it up the right way. Clean up the bottom of your plate that runs along where your thread is, so when we weld on the other side in earnest, it's a nice clean weld, not into mill scale. And get these plug welds in place. Obviously, guys, like before, you make sure you take your bearings off before you do this, rightio. And then we're just going to weld. Now make sure, guys, that you have overhang. All right, you have roughly 10 millimeters overhang here to get your weld along. Here, sorry, I should have mentioned that before I plug welded that. But yes, make sure you've got enough overhang. I mean, if this ended up being right flush with that, you can still get a weld right along there, no problem. A little bit of overhang will be good. And weld this, guys, in this position so then your weld goes into your cracks here at the front. Then turn it over and weld the same way this way. Okay, guys, if you're hanging in there at the moment, then you're doing really, really well, all right? Now, with either a ruler or your veneers, it's up to you guys. From the front here, so where our top plate that we are going to now weld our uni joint onto, where that sits on top of our trolley here, so this is the front of our trolley, all right? You want to measure in 40 millimeters. 40 millimeters from the front edge in, mark that. I just marked it with some white marker or with a Sharpie, whatever you have. 40 millimeters, mark those two marks in, guys, and then draw your scribe in. Now, if your scribe's starting to get blunt, like mine, you can just do this. And you'll have a sharp scribe again. So get your ruler across those marks, 40 millimeters in from the front, scribe a line in, okay? Now you need to measure a line straight up the center. Now I still had my mark there from the veneers when we did that mark in mine, so I'm just going to try and scribe that in a bit better. A bit stronger again. Okay, so I can see those marks. Now that, guys, is ground zero, all right? Now this is going to be a bit tricky because this is going to vary between uni joints and what uni joints you can get hold of. Now the next part is going to be a little bit tricky to relay because at the end of the day, this is going to come down to your uni joint selection. Now my uni joint for this 4 degree of freedom motion sim has come from my 3 degree of freedom motion sim conversion. This was the original uni joint on my 3 degree of freedom motion sim. This is part of the magic of the 3 degree of freedom motion sim. Now, the 4 degree of freedom motion sim is going to benefit from this. It's a very large uni joint. This uni joint is out of a Cat 3 tractor PDO shaft, so it's large. A uni joint from a vehicle, which is what you're going to have to access. I doubt you'll be able to find one of these. You could go out and buy one of these from a tractor parts place if you wanted to, but it'll be quite expensive to buy something like this if you were to buy a Cat 3 tractor PDO uni joint, or knuckle as they're also known, because it comes with the telescopic shaft. It comes with the whole lot, guys. It couples a implement that gets put on the back of a tractor to power that implement, so it's overkill. You'd have to buy the whole shaft. It cost you $300 or $400. You know what I mean? A lot of money. So what you'll do is you'll go to a car wrecking yard or a metal recycler and you'll try and find a tail shaft uni joint from a vehicle, whether it be a car, a van, a truck, a ute, and all you'll do to get the same finishing height I'm about to give you, because it won't be the same, because uni joints in vehicles are much smaller than this, they're more compact. You'll need to just, when you cut your uni joint out of your tail shaft, well, your uni joints will be at each end of your tail shaft. You'll need to include enough tail shaft connected to the uni joint, so you'll need to cut your tail shaft. To cut your tail shaft square, you'll just wrap some tape around it. All right, really, really carefully. Make sure that where the tape starts and where it finishes, that it marries up and it joins square, and then you'll have a square cut to get your uni joint tail shaft cut nice and straight. And you'll need to cut that tail shaft once your uni joint is straight like this, all right? And you'll need to cut that so then uni joint and tail shaft equal. Let's have a chat about ground zero. Now this is a very, very important measurement to get your top frame aligned with your mid frame. So with my universal joint, so I've got a few little things on this particular uni joint which make my life a little bit easier to find the center marks of my uni joint, because this is cast and put together. There's a cast line. on both sides that go all the way down to the center of the bearing caps. As already discussed previously, guys, on how to line this up. With my uni joint, guys, I had a very large piece of 50 by 100 piece box that sat on top of this for the previous 3 degree of freedom motion sim. I've cut that off, and it had some 75 by 5 mil plate welded onto this centered before I put that big piece of box on. And once I've cut this off, that's what's remaining, because that 75 by 5 mil plate was already welded on to the uni joint. So this is what I've got remaining. It's all weird measurements because of the way that I had to cut that box off. So I couldn't really go off anything here to get a center mark or anything on this. I could only use my castings here, which run from the center of my bearing cap, and I've marked them on the sides. And on the top, where the center is on this piece of oddly shaped flat. Okay, now when you go to weld your flat on, you will get yours a nice square piece, okay? Regardless of how square it is, you need to find the center of your uni joint to weld this onto your tail shaft, because that's what you're going to have this end to get your height for this. So the new finishing height for this, guys, is no longer as high as mine was. So from the top of your trolley to the very top of your uni joint, this is your finishing height. This is important, an important measurement, guys. It is 220 millimeters. So that's what your finishing height of your uni joint with your added little bit of tail shaft to give it the length you need. That's where you need to finish here, okay? So you need to include a little bit of plate. So some 5 mil by 75 flat is an ideal thing to use. So you need to take that 5 mil, it's going to go on top, into account to make this a finishing height of 220 millimeters. Then you'll need to mark the center of that plate that you put on, lined up with the center of your uni joint. I would recommend that you weld the top connection to your tail shaft pipe, and that you weld your uni joint straight onto the plate here, because it'll make it much easier to align this. Now, the difficulty with getting the uni joint on your plate to those measurements I've just given you, 40 millimeters in, because basically this is sitting, guys, right on the front. So then the weight of the uni joint's over our two rods. That's what that 40 millimeter measurement was in from the front. We'll center your uni joint to where the weight is over our rod, okay? And that's your center mark to get this also aligned this way. So that's a bit tricky with something like this that's round. So you'll have to go off your bearing caps, all right? This is how I lined mine up. This is how you'll need to line yours up. Actually, I was able to cheat with mine because my uni joint here has these pins located right in the center of both sides of this uni joint. It made it easy for me to put a square on. All I needed to do, guys, was line up my 40 millimeter lines with the center of that pin, and I knew that this was both square, done off both sides, and in the right position on the plate. For you, it's going to be a little bit trickier. You'll have to do what I did originally when I first set this up on my 3 degree of freedom motion sim. Whoops. This is the nature of universal joints. You will need to find the center of your bearing caps, okay? These ones, the ones that are going to run to your 40 millimeter mark. You'll need to find the center of those. You can see this cap is marked. This is, like I said from previously, with my old build. And you'll need to line your square up between the center of your bearing cap down to the 40 millimeter line here to get that centered. And you'll need to do it both sides. It's going to be really fiddly. You're not going to have this finishing top. This is from the 3 degree of freedom motion sim platform. This is about to change anyway, so we won't go into great detail about this at the moment. All you'll need is that finishing height that I just gave you. Unfortunately, because I've already got this set up and I don't have a tail shaft build per se, I can't go through that with you step by step. That's going to be dependent on your tail shaft But like I say, I advise you to put your uni joint itself straight on the plate so you can access these cap measurements easier. Don't have too much excessive pipe or tail shaft itself. Make sure you basically cut your uni joint off the tail shaft right flush. Leave your pipe on the other side of your uni joint. That's how I'd go about it to get this lined up. Now guys, this is very important to get this lined up on this plate, okay, because when it goes on here, this is all square and this is going to align our top frame. If we don't get this uni joint on this plate straight, then you're going to risk having a skewed top frame. Okay, this has to be square. Let me give you an example. This has to be square on here, all right, because our plate's square. If this is not square and this is twisted, I know the plate's twisting, don't worry about that. If this is twisted, obviously your top frame is going to be twisted to your mid frame. It's going to be skewed, should I say, to your top frame. So you have to get this aligned perfectly straight, because your top frame sits on this and your top frame has to be straight with your mid frame. A lot of things about this build take time. It's not a race. You want to get it right. If you don't get it right, especially things like this, then these measurements, if they're not right and you don't have your top frame following your mid frame, you're going to have problems with your motors. You're going to have problems with your IBT2s. You're going to have problems with your power supplies, because all of these misalignments will add extra pressure to your motors, because your motors won't be aligned onto their connecting rods properly, and you'll load one motor more than the other motor. That in turn will load your IBT2 controllers. That in turn will load your power supplies, and you'll have all sorts of problems like that. So these measurements are very important. To take your time. I took a long time to get this set up. I kept double checking, measuring. I would bring my ruler in and then double check measurements between the outside of my plate to where the uni joint was sitting, making sure everything was aligned, because it will just save a lot of headaches further down the track. If this is not right, you won't be able to fix other problems, because this will be your root cause, and the only way that you'll fix this is to cut it all off and start again. So don't rush this, take your time and get it square. Well, that is your lot for today. So until I see you in the next tutorial, you guys stay safe, stay healthy, and take it easy out there.